শেয়ারিংটা কে বন্ধ করবে?
স্ক্রিন শেয়ারিং বিবেক
বন্ধ করে
তুমি স্টার্ট
বন্ধ করে দিয়েছো? রেকর্ডিং তাহলে স্টার্ট করছি। হ্যাঁ, okay, so a very good afternoon to all the a very good afternoon to everybody present in the audience today. Our head of the department, colleagues from my department, all the colleagues of our college and faculty of the different colleges and universities who have joined us, and our student participants who have joined us from our country and elsewhere. Welcome you all to the second day of the 8th webinar series organized by the Department of Physics, Acharya Jagadish Chandra Bose College, in collaboration with the internal quality assurance cell of our college. And the name of the webinar, as you know, declared yesterday, is the recent trends and scopes in physics. So before we start our second technical session today, let me once again give a gentle reminder to all our participants to kindly keep your video and audio off during the entire session. There were some participants who had kept their video on and some who were disturbing with the organizers, as these are speakers, are eminent personalities who have taken time out of their busy schedules to spend some time with us to share their work. So I would kindly request all our participants to please keep your videos off and be muted during the entire webinar. I also remind you all that if you have any questions regarding the talk, then please feel free to post your questions on the chat box for those who are in the Teams platform, and those who are watching this live stream in the YouTube, you can please type your questions in the chat box over there. As and when the talk comes to an end, we will moderate all the questions, we will collect the questions and convey them to the speaker so that he can answer them as far as possible. So with that, I now open today's technical session, the second technical session of the 3-day webinar, and in the Advanced Key Technologies Division at the National Institute of Material Science, Tsukuba, Japan. And to introduce the speaker, may I please call upon convener of this webinar and head of the department physics, Dr. Tushar Ghosh. Tushar, over to you.
Thank you, Kamalika ji. Am I audible?
Yes, yes.
Good afternoon, everybody. Today, we are pleased to welcome Dr. Anirban Bandyopadhyay, a very special guest from Japan. Dr. Bandyopadhyay is a senior scientist in the Advanced Key Technologies Division at the National Institute for Material Science, NIMS, Tsukuba, Japan. He obtained his master's degree in physics from University of North Bengal. He received his PhD in supramolecular electronics from the Indian Association for the Cultivation of Science, Kolkata, 2005. He subsequently joined as a research fellow at International Center for Young Scientists, NIMS, where he worked on the brain-like bioprocessor building until 2008. In the same year, he joined as a permanent scientist at NIMS, working on the cavity resonator model of human brain and design synthesis of brain-like organic gel. From 2013 to 2014, he was a visiting scientist at the Massachusetts Institute of Technology, MIT, USA. Dr. Bandyopadhyay has been recognized with multiple awards like Hitachi Science and Technology Award 2010, Inamori Foundation Award 2011-12, Kurata Foundation Award, Inamori Foundation Fellow, Siwa Society International Member, Japan. He has more than 70 international journal publications, books, and patents, including publications in Nature, Physics Review Letters, PNAS, Advanced Functional Materials, etc. The title of his today's presentation is Nanobrain, the Making of an Artificial Brain from a Time Crystal. Let us join for the fascinating journey to a new world that Dr. Anirban Bandyopadhyay has explored for the last 15 years in NIMS, Japan. With that, I invite with great pleasure Dr. Anirban Bandyopadhyay to deliver his lecture. Over to you, Anirban.
Thank you, Tushar, for the introduction. I would like to share my PowerPoint presentation. Thank you so much, whoever it is. Thank you, thank you.
Very sorry, Anirban.
I just liked it. Okay, so can you hear my, can you see the screen?
Yes.
Yes, we can see the screen.
Yeah. So if during the presentation, if both of your mic is on, that will be very good. Because if you have any problem, then you can tell me immediately, and then
don't worry about that. Surely, yeah.
So today, for the next half an hour or 40 minutes, I would like to tell you my journey. So I did my PhD in cultivation of science near Jadavpur, and I used to work on electronic device, making of electronic device, memory switching devices. But always my interest was how to build an artificial brain. And I used to think about this particular problem very significantly. And I read many. I'm fond of science fiction novels, and then here I have in Japan I have a kind of a small movie theater, and then I in my house, and then I watch movies. So I hear that in the 21st century, the biggest problem for mankind would be to understand how the brain works, and it is the most difficult problem of all. And so when I got the opportunity to write a project in Japan, there was an international competition. So from cultivation itself, I wrote a project on how to build an artificial brain. So some people thought that this is one of the most craziest ideas they heard. So they invited me. From my PhD, I went to Japan and I started working since 2015. So I thought that when my age will be 40, I will finish the research. I will build a prototype of artificial brain. And so I did. And then I compiled my journey in this book, the book that cover page that you are seeing. And the temple-like architecture that you are seeing on the cover page of the book is the core architecture of the brain, or could be the universe. So I'm physicist by background. So to build the artificial brain, we hired some chemists, some biologists, some neuroscientists, computer scientists, and many other people who have worked with me for the last 15 years. And today, the journey that I will be sharing with you actually have credit. The credit goes to more than 40 scientists and more than 10 or 12 professors all over the world who have worked relentlessly and believed on my crazy ideas for many years. So let me get into the topic. I would like to mention about Akshapada Gautama, Maharshi Gautama. Long back, he wrote Nyaya Sastra. Many of you may know what is Nyaya Sastra, but what he said that to solve a problem, you do not go and try to find out what are the facts you know. So normally, when psychologists tell you that if you want to solve a problem very nicely, then you go somewhere and try to find out facts or truth. Then you combine those truths into one model or system and then verify with many future predictions, and then that model is accepted. So this is how the physics works. So I have always been a very big fan of John Archibald Wheeler. Wheeler was the PhD supervisor of Richard Feynman. I think Feynman's name many of you know. And few of you know about Wheeler. Wheeler started in 2019, nearly 101 years back. He started suggesting that everything in this universe is processed geometrically, and that he named geometrodynamics. In 1974, his PhD student, Richard Feynman, he wrote a book that one day all physics changing on a checkerboard. So in 2010, we published a Nature paper on actualizing his dream, Feynman's dream, that can we write some patterns and that will replicate radioactivity, diffusion equations, basic equations that you read in school textbooks. But if many of you, I think only very few of you know about Indian philosophy and its history of decision making and others. So for 3,000 years, Indian scholars or Indian wise people, they used to argue that it's not fact. Normal computers use facts or bits or qubit. If you talk about quantum, then qubit. That means yes and no. So what do? Every single problem of the universe is converted into a small thread. I mean, a very thin thread with 0, 1, 0, 1, 0, 1. It could be infinite length, but it's called a Turing philosophy, or what the basic philosophy is. Whatever is happening in the universe, it could be written on a thread, on a single line. Dot 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 dot. I mean, 0, 1, 0, 1, 0, 1, 0, 1, a bits like thing. So based on this particular principle, most of the scientific theories, almost all the scientific theories, whatever you see in physics, or in mathematics, or in engineering, has been devised. Suppose I am a life form. Inside me, there are some life forms. Inside that, there are some life forms. And then whole universe could be alive, and then life inside life inside life. This Gautama Maharshi, he started saying that, no, not just life inside life or universe or locus or no. Even the logic, if you take a logic, inside that logic, there would be some other logic and some other logic. So there is no statement or fact in the universe. So what you have is confusion. So scientists or philosophers, great philosophers of today's time, in India, such studies are not done. But in Harvard or some top universities of the world, they do study very intensely, and they call it doctrine of doubt. So doctrine of doubt is actually what Indians could be identified with, because they went on a completely different journey of finding out confusion. So you go and try to solve some problem somewhere, then you ask, you don't try to find fact, what are the truth. You try to find what is the most important thing which you absolutely don't know. And how do you find confusion? What is confusion? Aksapada Gautama defined it in such a way, if you read it, you will find it as if some scientists have written a very classic definition. So in your mind, if you have of occurring that particular event, or it can have multiple different outcomes. So you cannot tell its origin or future. So your mind is confused between two equal probable systems. It could be cognitive or non-cognitive, but you know that it's supposed to happen, but you don't know its origin or future. Then it will be called a confusion. Now let's get back to simple systems. Suppose we want to go inside inside our body. It could be a giant oscillator. Then inside that there could be some more oscillators, and you take one of them and you go inside some more oscillators. You can go inside, within and within and within. Let's try to understand this particular thing also very well. So you can take a pixel in a circle. Circle could be a clock, and then you could get inside clock inside a 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 clock. It could be an infinite way of making journey. So what I would like to suggest is that if you are all not aware of the current information theory that is there for the last century, based on which most of the scientific theories are built. So what happens there is all the events that are happening around us could be rewritten as yes, no, yes, no, yes, no, yes, no. The questions that you can ask whose answer will be yes or no, and you can frame many questions, and on a tape you can write. But we are suggesting, based on our experimental adventures for the last 15 years, we say that no, events are topological. Suppose there are 3 events, 1 event, 2 event, and 3 event, like a triangle. Then you can go inside an event and you find that there are more 4 events. Like I can say that today, after whole day work, I have come here to give a presentation. Whole day work. So if I take the event as whole day work, then there was a time when I was working on mathematical problems. There were times when I was looking at some of the experimental setups I was checking, and then there was a time when I was listening to some songs. So there could be 3 events. And then when I was solving the problem, I can enter inside that and I can find that I did some mathematical problems. I did some neuroscience related problems I was looking into. So I can take any event, I can go inside and inside and inside and inside and inside. So it could be an infinite or endless journey. So what Maharshi Gautama and all the scholars, you won't believe, there are at least 40 to 50 different schools of discussions were there on doctrine of Tao in the last 3,000 years in India. And almost all of them say that you go inside a confusion, and take one of them. Inside a confusion, you find some more confusions. You go inside and inside and inside and inside until you reach facts. And how do you reach fact? When you try to find the source of an event, then you reach the fact. So thus you get an architecture of confusion. So this is a new way of thinking. If any of you are very interested in physics, then you should read. Every physicist, I believe, should read the book, the paper, which is freely you can download from internet. It's called, the title of this paper is called Eat from Bit, written by John Archibald Wheeler, where he argues that when you convert every single complex event of the universe as a linear tape, 010101, then you lose all the information. Then what you do? You use your own imagination to bring them together, and then you try to fit the result, output observations, and then you try to create it. Now you propose a particular methodology how to do that. So what happens is, after you propose that theory, many people come and you try to get their support. Now, once you get a lot of support, how do you get the support? Those scientists follow the exact experimental protocol that you have suggested, and they say that, okay, if I follow your route, I get this result. If they follow other route or other results, then they will not be able to do so. But that's how you start creating systems that works. That works means you can instruct something and you get some output. And that's how the concept of machine came, and then whole humanity got revolutionized. Okay, so this is a work from Nature paper. So there were a group who were working on particle simulation. They were a group of physicists, astrophysicists basically. And what did they do? They took the gas particles and then inside a cavity, they started collapsing the gas particles, and then they found that after collapse, it looks like the collapsed structure looks like the whole universe, and that looks like the neural network in the brain. So one-to-one correspondence was so much, it was astonishing for the entire scientific community of the world, and that's why they published it in the Nature journal, and it was. I mean, there are many papers published in Nature journals which are not so much breathtaking, but this was really a breathtaking moment. So now I would like to tell you something about imaginary world. So you know complex number. Complex number is like a plus ib whole square is equal to a square minus b square plus 2iab. Almost every one of you have seen this equation. And b is an imaginary world because I have put I in front of b. And so a square minus b square, when you write, both are real term, right? When I write whole square. So minus b square, where does it come from? It comes from imaginary world. And you look at the output, there is 2iab. So this a part has actually gone from real world to the imaginary world. So this is the simplest example where you show that an imaginary world and the real world is interacting. Actually, mathematics does not say anything, but those of you who are very well versed with the quantum mechanics, they know that imaginary time is there. So if I put real time and imaginary time, this one will become extremely exciting thing, because you will be able to say how the imaginary world is interacting. If we think of biological systems, then we will find there are clock inside a clock inside a clock inside a clock inside a clock. So you get every 11 days new skin, every 3 months new blood, every 8 years you get new bones, you get 100 years you get a new heart. So every single every single organ in your body is getting replaced in a clock, and those clocks are nested one clock intricately. Each clocks are forming an architecture. Almost all of you have heard about material science. So where materials come together, atoms come together, and then they build an architecture. In the 1960s and 1970s, because of virus was so intelligent. At that point of time, people wanted to find out why and how virus becomes so intelligent. It has only few protein molecules, and it is so intelligent that you come up with some antibiotic, and then after some time it comes out with some little conformational changes which helps it to make the antibiotic or antiviral systems fail, and then you don't know what to do, what to treat. So even inventing antivirus is very, very difficult. So people wanted to find out, and then they came up with an idea that instead of looking into the materials, we should look at the clocks or rhythms of life. So the rhythms of oscillations of vibrations of those proteins or other structures, those clocks are actually forming another kind of material which does not use any atom or physical object. But the clocks, they come together in a 3D space, arrange themselves, and they act almost like a materials. So they called it time crystal. So if you remember, the cover page of my book is The Making of an Artificial Brain from a Time Crystal. So I have always been a very fan of this time crystal concept, time crystal research, which started 1960s and almost 2008 got finished. So the there were huge amount of research for why after 2000 people stopped working on this particular research field. I have absolutely no idea. But 2012 from MIT, Frank Wilczek, a Nobel laureate, started working on time crystal again, and he popularized it again. And we also started working on time crystal or the clock architecture. So it is just like different clocks are arranging together the same way you think of nanoparticles, supramolecular structures, many molecules come together and then come together. Similarly, you just think that there could be a futuristic world when clocks will be connected together. Clocks will be connected. Now you can ask me, how stupid idea is this? How come lots of clock come together? I mean, clocks are not visible. I mean, they don't have any physical existence. Actually, material will come together. But how materials are coming together will not be important, but material will come together in such a way when they vibrate, then clocks will be interacting with each other in a very particular fashion, like an architecture of clock. I repeat my sentence because that is the only message I want to deliver through this presentation. So what I'm saying is that materials, suppose you bring a pen, you bring some chocolate, you bring some, say one pressure cooker, you bring one pillow, you bring one light, you put them together, they vibrate in such a way that you beautiful flower clocks you observe. So flower-like arrangement of clocks have nothing to do with the component or materials that you have done. Of course, something to do, but their arrangement, their structures have nothing to do with this. But they vibrate in the vibrational space or in the time domain, you observe it. So it's a very new, I mean, of course, it's an old concept in physics, but it's very new that people have started discovering it, that it could change the engineering of the, not only engineering, but also the understanding of the universe very much for the physicists and others. So breaking of time symmetry is very exciting phenomenon in the current world right now. And then we have made some significant contribution in that. Now, many of here you can see 4 pictures. In the right hand side, you have 2 pictures, top and bottom. This is the head of a normal person. He has got something. And in the left, you have head of a person whose brain is empty. Of course, I know many of you have thought, some of your friends have got the brain just like the left part. But believe me, the person in the left, who has absolutely no brain, entire brain is empty, that person also thinks like a normal person, similarly intelligent. And then this is actually the head of a person, 44 years old person from UK, who has got kids, and then he is doing very nice. So for the first time in the history of mankind, in 2014, humanity took up multi-billion-dollar projects. All the developing nations and developed countries except India took up the project in from 2009 to 2013 it was made. 2014 started, 2013 started. So for the first time in the history of mankind, we started project for making artificial brain. And artificial brain was such that we will copy all the neurons inside the brain. Neuron will be like a switch. So we will take switch, we will put them like a computer circuit, and then we will make a brain. So that is a simple idea. But we challenged that. So from the very beginning, from 2005, when I started my research, I thought that this idea of events in a linear fashion and all these kind of things are very stupid. Brain must not be working on that particular platform. So I started finding out. I took the brain, extracted the brain material, and then started neuroscience lab, and then tried to understand it. And then I also had a physics lab to look into things. And then this is a Chinese lady. So up to age 23, she was very fine. She was feeling a little bit of nausea one day. So when she went to doctor, the doctor asked to do MRI. and then they found that she doesn't have cerebellum. So if you know a little bit of brain science, you know that without cerebellum, the science tells you that you can't move your anything. You can't speak. You cannot move a single muscle. So muscle coordination, that means, you will be just like a zombie or you will go to coma. But this lady was doing fantastic. Okay, so there are many informations where brain architecture was not doing anything. So could it be a time crystal? And how the materials are arranged doesn't matter. It could be that all this whole brain is full of water, cerebrospinal fluid, and then a little bit of thin brain part around the skull you can observe. And they actually do whole thing because they all you got to do is to build the clock architecture, nothing else. So that is what came to my mind. And then I started. So we are the only group in the world who started in a completely different direction. Every other group in the world, even now, trying to realize artificial brain, considering brain as a computer circuit, except us, because we think that clock architecture, 3D massive clock architecture, is the reason. Let's do some mathematics now. I hear that most of you are physicists, so you can do this particular mathematics. Symmetry. Symmetry is like half of your body, left part and right part, are similar. So that is called C2 symmetry. So how many objects or how many integers in the universe are divided by 2? 50%, because odd and even, right? And if you take 3-3 symmetry, then 33.33, but some of them are divided by 2, so it will be 16%. So if you try to find out, if you try to explain in the world, how many symmetries should I take to understand 99.9999%, then you need only C2 symmetry, C3, C5, C7, C11, C13, C17. These are the prime structural symmetries. If you know only 15, then you can. So it means 16 billion years before, when the universe was being created, even then it was true. And 16 billion years later, when none of us will be alive, and then we don't know whether humans will be there, a completely new universe could be formed. And even then, this particular fact that only 12 to 15 primes cover 99.99% of the universe. So 16 billion years from now, a person, if look around himself, he will find 50% of the structure following C2 symmetry, 50% of the events have the possibility of reverse truth. And then many other things, because we physicists, how do we think? We think that always symmetry or ordered arrangement is breaking. That's why an event is taking place in the universe. So this is like religious statement of every physicist. I mean, all of us. I mean, we try to do that. Now let's try to do a little mathematics. So we are also only one group in the world who wants to build an artificial brain without using any software. So no software, no code. Because when I'm talking to you, believe me, I have not prepared. Even the next sentence, what I'm going to tell, I have no idea. And some of you are able to make out something about what I'm talking. At least to some extent, you have to just try to feel, because you are seeing a completely different kind of science fiction, like work that we want to actualize, and so you don't have to necessarily understand everything, but you are at least able to guess what this person wants to take us, where this person wants to take us. So, but nobody told you. Even if you go through a website or somewhere, nobody told you what I'm going to say next, because even I don't know. So a computer can never, ever do that. It cannot say even a single sentence if it is not instructed to. So that means computer needs an instruction. But how can I make a computer or a processor or a system that operates by itself? Like the universe, we say universe is self-operating because we are a student of science, so we don't believe in God. So we say that the universe is self-operating. So how it is self-operating? So we do a little math. And you all know this mathematics because when you all were at the age of 7 and 8, you learned LCM and HCM. If you are Bengali, then Losagu, Gosagu, Logisto Saran Gunit. I don't know how many of you remember the Bengali word, but suppose a random number of events are given to you, 1, 2, 3, 4, 5, x-axis. If you look at number of randomly number of events are given to you. Now you are an intelligent system who does not have any brain. Okay, so what you do is you take the event and you arrange them in every single way possible. Okay, so what will happen that whoever gives you the event, you will arrange them in every single way. So you will be, even though you are stupid, you will be able to estimate how many ways those events could be arranged. And that's what we physicists want, because we want symmetry breaking. Arrangement would be there and arrangement would break and become a new arrangement. So we'll be able to tell how the events are going to happen in the future. And that is the objective of science. That is the objective of physics modeling. So now in the x-axis, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you see 6. You can take 2 balls at a time and you can make a triplet, or you can take 3 balls at a time and make a doublet. So 2 ways you can do it. And then similarly, 8, you can do it in 3 different ways. 12, you can do it in 7 different ways. 4 into 3, 3 into 4, 2 into 3 into 2, 3 into 2 into 2. So if you first take 2 balls and then you group them into 3, and then you again take 2 of them and then form a group and you get 12. So all the ways. So what will happen? Each sphere here, each ball is like an event. Okay, and so you know how to arrange them and do it. Now, if you rotate this one, why do I rotate it? Rotate this plot because you will rotate it because 99.99% of the predictions you can make if you know only few symmetries and how do they break. So it's just like a circle and you rotate it and then you get it. So how does it happen? So the same plot I have done it for 400,000. So left part is 400 0 1 2 3 4 5 6 7 8, and right hand is 400,000. And simply we did LCM HCM like calculation that how many different ways you can arrange a number. So how many different ways you can do it, and you get this core architecture. So this is the core structure of our artificial brain. So we make materials so that they vibrate, and all these possible symmetries they can generate and then replicate all the possible things as much as possible. Absolutely, this is an absolute mathematical pattern which we cannot realize in practice, but definitely as much as possible we try to go as close as possible to this idealized structure, because if the system, we call it brain jelly or organic jelly, if they follow the vibrations and then pattern like this, then we can build a computer. Since this is very important, I go back again. So what we did, we found that around us there are C2 symmetry, means if you cut by half, it will be mirror symmetry. Both sides would look similar. C3, you see this is starfish. It's a 5-fold symmetry. So C5, and so in this way you find that if the contribution of each primes or the prime related symmetries, if I add, you go nearly 100%. So we will create a system so that we can access this. And then we do some LCM, HCM, that some stupid guy who has absolutely no idea about anything or what is called event or anything, he goes and starts counting and grouping, and then he gets a pattern, a temple-like architecture pattern, and that pattern is actually the core structure, because that will make decisions. Now, another interesting thing. So many of you know phase sphere. What is phase sphere? That in quantum mechanics, if a sphere is there, top and bottom part are classical, and then from say North Pole and South Pole, you can go from North Pole to South Pole in infinite possible ways. We changed that concept. So this is the concept of time crystal. What happens is you consider that every single information is geometric, like a geometric shape. So that means an event, there could be at least 3 events, and then they come together and form a triangle. Now, when you start getting into that, you can go inside an event and find 3 or 4 more events. And then you will find those spheres are actually new events. You go inside the singularity or confusion and you find some more confusions over there. And then this way the journey continues. And this is how the information structure looks like in the universe as well as in the brain. So we got this experimentally measuring systems, many protein vibrations and others. So now what happens is I have shown you that a stupid guy will follow this temple-like architecture who understands nothing, and then using it will try to fit those fate spheres and combine them together to create the information structure in the universe. Okay, so once you link between the two, you know what is your core structure and how do you create information. As I told you, that clock means any single event happen periodically. That means you start with something and then you end and come up with something. Then you get a circle. And then on a sphere, there are many possible ways of linking the events. So what we have learned so far, here is the summary, that if I have a frog and then if I go on finding periodic structures in the frog's body, then I can convert it into nested spheres. So many spheres are together. So on the diameter of every sphere, we'll find a clock. So it's a it's an assembly of clock architecture. So the concept is not new, as I said, in the 1960s, 70s. What is our contribution? We created a generalized way. Earlier, in the last 40 years or 50 years of research, they put one circle, one sphere, and then one guest on a host sphere. But we have created a model by which many spheres can go within and above self-assembly. So what we want is actually the temple-like structure-based hardware and some artificial events that are around us. They will come together, enter inside my temple-like architecture and give the output as if something is happening. So what do we do with this? This is SARS-CoV-2 and ECE2 are human receptor cells. And then when I don't wish that some of you get infected by corona, but those who get infected by corona, something like this happens inside his body. So in the cell receptor, the CoV-2 comes. We looked at many different species who got corona, and we found that there is some hidden intelligence, Indian geometric intelligence during the evolution process of virus. Of course, virus-related intelligence using time crystal is very old. That is the oldest work in the 1960s, 70s. But because of the corona situation, we started our model, temple-like architecture, and then geometric self-similarity, and to find out how it could happen. So we plotted 1, 2, 3, 4 and dotted with many different kind of species by which this junction, the junction used for the protein junction, there are 4 points by which coronavirus actually attach to your body cells, body proteins. Okay, so there are 4 points, but for every single animal there are 4 points, and while practicing with different animals, it follows a particular pattern. This is spiral vortex-like pattern, and it's trying to going towards the center. Why? Because if it can lock by energy minimization to the center, then what will happen? The coronavirus will be almost, it will go to entire humanity. I mean, nobody can get saved from it, because if it touches you, and then it will enter. So now, how did we get all this knowledge? So this is called a neuron. You are a physicist, most of you, so you have little idea about neuroscience. So this is called neuron. Inside the neuron, they call it, they think that there are some fluids, but we found that there are some strings, just like musical instrument. They are called microtubule. And let's listen to this music. Can you get the sound? Can you hear the sound?
Yeah, yes, we can.
Yeah. So this is a sound when your brain is thinking. So neurocells are firing. So this is the string inside the neuron, which we discovered. We found its rhythmic oscillations or vibrations. So there is water core, that is the blue color. Protein is red and golden, and green color is the extended part. So they vibrate at different clocks. So clock inside a clock inside a clock. So they form a time crystal. And inside the protein, you will find this kind of spiral structures are like there, just like spring. So spirals are everywhere. If you go to the galaxies or to the deep inside protein secondary structures, everywhere, because they want to play music. So we imaged the protein vibration, the dance of the proteins, and then also recorded the music. And then we checked, this is a band diagram of the materials. If you are a physicist, you know the broken band. So valence and conduction band are actually bridged. So this is the sound that you are hearing is in one neuron firing. So up until us, our work, people used to think neuron fires and that is everything. But we challenged. We said inside the single firing or single tick, 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 you will find a complex 72 frequency music that you are hearing now. I'm stopping it because I'm wrapping up. So the brain evolved over 75 million years from dinosaur to complex humans. And then this entire evolution process to us, we should not be concentrating on how the entire cortex region become complex and become giant. We should be thinking how many different oscillators are we adding? How many different regions are we adding? How many different clocks we are adding? So we should not get, so that's why we are challenging the whole world, the mind, the way people are trying to do it. So on the top of your cortex, very thin few millimeter layer, there are hexagonal close packs, structure of cortical columns. So this is when you think how your brain top surface looks like, where all your conscious thoughts are created. So your conscious thought is created in every 200 milliseconds. For that to happen, your neuron fires in every millisecond, tick, 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 tick. For that to happen, inside your neuron, there are some musical strings called microtubule. They fire every microsecond, tick, 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 tick. For that to happen, there is some protein inside those strings, and those proteins actually vibrate nanosecond, tick, 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 tick. For that to happen, the secondary structures inside vibrate in picosecond, tick, 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 tick. So this link, this fractal link of vibrations, clock inside a clock inside a clock, is our discovery. So we experimentally found it and we published it. And the whole book is actually work. So if that is so, clock inside a clock inside a clock inside a clock. So you can take the whole body of a person and then you go clockwise and then you complete up to atomic scale. So whole scale is there. So we will not look at the physical structure, we will look at the temporal domain to create the clock architecture like this. So this is the whole brain map. We are the group who have worked for 12 years to map the entire clock architecture of the whole brain. So this is the only clock based. So we do not look every single component which forms a clock, which rhythmic shows rhythmic behavior, we have put into it. So my PhD student have done this work, and then we create artificial nanosystems like artificial life form. So this one we created 2013, 2014. Now we have created much more complex things. So these are molecular machines at the top, and then molecular machine actually absorbs the energy, then it goes to the local conformation region. There are sensors, there are motors, there are decision-making multi-level switching molecules, and entire thing is packed within 10 nanometer. So we call it the nano brain, and but now we have built the very massive structures of final prototype. But this can be used to build antiviral systems, or it is just like a submarine that could be injected inside your body, and it can make a decision by itself. And this is the current latest version of brain jelly that we have. These are the experimental setup where many different information goes in. So like a kangaroo is running, it goes to the jelly, and then the jelly looks like a little bit different, and then finally you get the output. I will not talk about. Let me talk about a fourth circuit element a little bit. So the device that we are making, you are physicist, you know capacitor, resistor, inductor, and everything. And capacitor means it links voltage and stored charge, and resistor means it links voltage and current. Inductor means current and flux. We need another element. So all these three elements were discovered 1840s, 1850s. For 150 years, people were trying to find the four circuit elements. So memristor was proposed, but we challenged it, and we created another kind of four circuit element, that is inductor. We patented it in 2010. For the last 10, 11 years, we have built it, and now we are trying to commercialize it. So what you do is you store charge in the body. So why do you challenge the other groups? Because they were doing voltage and current, regulating voltage and current, not stored charge and magnetic flux. So we stored charge on the spiral. We took a spiral structure. Spiral device is our unit device for the brain's decision making. And then these are surface traps. So charges rotate in the traps continuously. So the light, when it comes, it goes out, and you get magnetic vortex. So that was proposed by JF9. Actually realized it, and we linked stored charge on the surface. So surface charge storage pattern changes and magnetic vortex changes. Created many different kind of vortices, and with frequency we could tune. This is the Hamiltonian we created. This Hamiltonian. I don't want to explain, even though I know all of you are physicists, but you are not here to learn physics. You are here to just to enjoy a different kind of experience of different kind of doing science. So basically, we created a Hamiltonian for the device so that we could link magnetic flux and stored charge. And this is quantum cloaking. Your physicist would be very interested. You know classical cloaking, something invisible turns invisible, but in the quantum tunneling domain, if something gets invisible, the DNA, it vanishes, and then we could intentionally we could bring it back, and we did it many times. And using this kind of vanishing materials, and this fourth circuit element, we created the brain jelly, and we are preparing for the commercial version, and we solve many different kind of problems. For an example, a cheetah is running, and then we could find out cheetah's dynamics using optical vortex. So we give input to our brain jelly using electromagnetic wave, and we read the information output using light. And many problems like detecting classical raga, Hindi Bollywood songs. So we try to solve many unknown problems. And so finally, when I end my talk, I would like to show you, after all these 15 years, then we started building the prototype where we could test our organic jelly or brain jelly. So we created this starting from skeleton, because in our brain model, we have a clock inside a clock inside a clock. So massive clock architecture. So we have to build all the clocks in the body. And then we would read the brain data using EEG, just like a human brain. So this guy is there actually in our lab, and then he sees everything, and then we read it from his brain what he is understanding, how he is understanding. We are making some chatbots. So these are the cortex layer, top layer of the brain. And then the board gets finally ready, and then it doesn't have any software. So we are creating the cortical columns, the hexagonal close packing cortical columns that I showed to you in the real brain. So we put brain jelly in this tube. So this is the brain jelly, and then we touch with capillary action. The brain jelly enters inside the cortical columns. So your brain have 200,000 cortical columns, but we have used only 10,000. And with light in the darkness, we were checking with laser the vortex output that was coming up. So we put a magnetic layer, and then this is the EEG pattern of the brain. and we try to build this. This is a very, very primitive prototype. So it took 15 years just to understand how the brain works. Hopefully one day we will be able to do it. So this we have compiled in this book, Nano Brain. And there are 8 or 10 more books will be coming, because we have done work on building a new language for the nature. We have created new circuit element. We have we have done neuroscience, inner voice of neuron. So, and we have taken proteins from the brain. We have done it, and then we created a new algebra. Dodecannian algebra it is called, because octonian and quaternion algebra was there, but we have found that inside the brain there are 12 layers. So we create a new algebra. So all these will be in 10 more books. So one book has come out. So each book will be compiling our discovery. So very soon, one by one, books will start coming up. Movie made on our research, and it will be released. So they come regularly, and then they record our development. So many of you have seen the movie Sank Redemption. So the director and then the whole camera crew, they are actually doing this movie, and that is the end. Thank you very much for your patience, and I think that I have taken nearly 50 minutes, so we can have some time for some questions if you have any, or if you don't, then you can follow me in my YouTube channel. We have 10 lectures on the book, on each chapter of the book, and then you can drop the questions over there, and then I can reply over there. Anyway, thank you so much for your for giving me the opportunity to share my work and your patience in the weekend for this.
Thank you very much, Dr. Bandyopadhyay, because just one second, Bappa, there is an echo coming. Could you see to it? My voice is echoing, I think. Is it all right now? Okay, thank you so much. Okay, Dr. Bandyopadhyay, I was really intrigued, and the entire slides, entire presentation transfixed. It was no less than watching a science fiction movie, and to think that science fiction movies are actually stories that we go to see in cinema halls, and this is actually something you have been doing, and you are doing it every day. This is what you are doing for a living, and it was really intriguing. I mean, I'm really awed. That's all I can say, and I'm sure the entire audience have also enjoyed your talk thoroughly. And to think about that, we really did not know that something of this level has been going on for so many years back in your lab. So yes, there are some questions, and I know you are really fatigued at the end of the day, but first of all, I'd like to tell you that there are some people who wanted your email address, if that is feasible, and if you could provide the YouTube link, the link to your YouTube channel in the chat box, or if you could give it to us, then we can.
Yeah. If your students know how to do Google search,
something that we can hear.
No. So conscious experience for us, conscious experience is 200 milliseconds. So in between 200 milliseconds, every single human being is a zombie. So you can't forget about inside your body. Even outside your body, if something happens very fast, faster than 200 milliseconds, you can't. Your cognition cannot happen. I mean, you can't do it. So if you are hearing some sound, that happens because of your perception. Human perception is something like it's a very complex process. You can see something and you can hear something in the brain. So you may search synesthesia and read further.
Okay. There is one question by Rochoita Poddar. She says, could you please explain a little more on clock architecture?
Actually, mm, uh, uh, clock architecture, understanding clock architecture in the first presentation is a little bit difficult. I should say that even our colleagues, even after all these works, they find it very difficult, because when I say that, for an example, me, if I want to understand a clock architecture, then inside my body, all the clocks are connected. My heart cells are right now getting replaced at a rate of 100 years. Right now, within 3 days, I will get a new stomach line. But all these in the temporal time domain, I can put these clocks connected to each other, but I cannot visualize it. So I'm sorry, we have to give time in our mind and we have to feel it, because it is not that we have to do that. As I said, that how can I tell you how to look at your heart clock? Okay, your heart clock is there. Inside that, on the pixel, you go and you find a clock for your stomach. You find a clock for your blood cells being replaced. So the understanding clock architecture is not possible by visualization. You may try to feel it as if you have a hologram, and you can go all around and then see the clocks are running. Tick, 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 tick. The best clock architecture is you have 60 seconds to understand what he's saying, because he is definitely not asking what he is saying.
Yeah.
Because what he is saying is, because every time when I look at something, optics or light wave comes through my eyes, and then definitely I see by doing that. So that is the simple answer to his question. So definitely he is not asking that. What he is asking, that when I am looking at a particular event, some more additional information comes in. So I would like to tell that this was actually the quest more than 5,000 years back, 5,000, more than 6,000 years back. The Vedic monks started asking, and they started, and many discussions went on for thousands of years in India. And then after that, they came to a conclusion that if I want to tell my what I want to say, or in a objects are arranged in a particular place, if it gives some more information, then those geometric shapes should have some meaning. Like in front of me, I have a fan, I have a light, I have a table lamp, I have a pen, I have my mobile phone, but they are arranged in a particular way that they give some other kind of perception inside me, and that changes my way of decision making. So definitely there are some more things into it, and those are the geometric arrangement of the things that you are looking at. You would be happy to know that this discussion went on so much so that there was something called Mimamsa and Mimamsa Shastra. So there they argued that if we really want to understand our nature, we need to invent a new language where every single letter has a meaning. And that's how slowly Sanskrit was invented by Panini. So Panini was not accidentally discovering something. It was a discussion that can we have every letter with a meaning that exactly comes. And Indian dance, you see mudra, those are the geometric shapes where you have a new perception that goes inside your mind. So people investigated. So that is a science. That is not an art form. I repeat, Indian classical music, you have a raga. Raga means what? Sarigama padanisa sanidapa magaresa. So you change, then you make ga up and ma down. So little change, and then whole night the song goes on by expanding that pattern. So what do? You expand the geometric pattern to create a perception of a particular feelings. Bhairavi means early morning. So I will sing a song, I will try to go inside you. So whole nation created its art to answer the question that Prasenjit asked.
That's why probably it's called Shastra.
Yeah. So they worked. I mean, not one person. There are hundreds and hundreds of them. I should say thousands of them, and not 1 year, one book. Thousands and thousands and thousands of books. Not 1 year. for 3,000 years of documented history to answer this question. So you go to any classical dance program, you go to any classical music program, you go to any roadside in front of the drain, this pujari is doing puja. Look at the mudra he is doing, and then something, and note it down, and you will find you will put it in Google and then do image search, and you will find how that is related to psychology. That person doesn't know. He is acting it in such a way that he has learned from forefathers. But that's how it survived. That's how it survived. The excellent level of knowledge that we need to again bring it back. The practices.
That was an excellent way of answering that question, Dr. Bandyopadhyay. Okay, Dr. Kinshuk Banerjee asks, in the movie Lucy, it was mentioned that we actually use only a very small part of our brain. Is that true?
I think that in the movie Lucy, because I'm a movie geek, and especially science fiction, Lucy is one of my favorite movies. But how much? Every part of the brain you don't need to use consciously at every moment, okay? But that is being used. My heart is being used when I'm thinking, okay? So all parts get vibrated. That's not the key feature of Lucy. What Lucy was suggesting is that every single entity in the universe are connected intelligently. So for an example, somebody is doing something else, far distant place, that would affect my life also. Here, who first said it? It was in Sankhya Darshan. Even in the Vedas it is mentioned. Sankhya Darshan, Maharshi Kapil first time argued that anywhere in the entire universe, if symmetry is broken somewhere else, Samma, they call it Samma. Samma is broken somewhere else it will be regenerated. So they were explaining the origin of this universe, and then he argued. So that was actually in our country. We don't make movies. Our movies are 200 ladki idhar dance karegi, 200 ladki udhar. That's Bollywood. But in the Hollywood, you will find that Upanishad and Vedantas, they use explicitly, like Avatar movie. You will find, if you know the scriptures very well, then you can see, oh my God, he's copied from this part, copied from that part. So Lucy was actually, what I was saying was Virata Purusha. Entire universe is one singular life form. So now I think the person who asked the question, he can get back to the last scene of Lucy, and then can match the Virata Purusha that was written 5,000 years back in this very country.
Kinshuk is an assistant professor in the Department of Chemistry of our college who asked this question. Okay, next question is from Dr. Anjan Chandra. He is an assistant professor in your alumnus, Malda College right now, in the Department of Physics. He asks, is there any quantum optimization kind of thing happening automatically in our brain?
Yes. Answer is yes. But what we did is, when we have clock inside a clock inside a clock, this kind of system, in quantum system, you have only one clock. So that's why in chapter 4 of our book, Nano Brain, we have exclusively addressed this particular question. And he can go to my YouTube channel, and then chapter 4 tutorial is there. So if he listens to entire tutorial, then he will find I have explained in details. If you have a clock, inside that one clock, then it's one imaginary world. One imaginary world is quantum, but you have another imaginary world inside another imaginary world, then you need fractal mechanics or some advanced form of fractal quantum mechanics, which Roger Penrose has argued for many, many years. So we have tried to propose that one.
Okay, there's one more question. Actually, this person has given 2 questions. How vibrations are governing to make time crystal, and why breaking of symmetry is occurring in brain as well.
So as a physicist, we all know that some ordered arrangement are there. It is shifting. So many places. For an example, in your brain, you have a hexagonal close packing of cortical columns, and they actually, suppose you have a hexagon, it changes its lattice symmetry. So hexagon becomes little deformed. That's how symmetry breaks. So if a pentagon is little deformed, or a hexagon is little deformed, or a square is little deformed, that's how symmetry breaks. So what happens is in the brain is your hexagonal close packing Even if you go to the microtubule, it has a hexagonal close packing of tubulin proteins. So everywhere the lattice proteins shift a little bit, very angstrom scale changes, little shift, and you will find we did the quantum tunneling imaging, and when we found that lattice parameters actually change. So this is how actually symmetry breaks in the brain. So I have seen it, and if you go to our Nature paper, 2015, we have a video free, or in my YouTube channel, I can upload that one. That is in the movie file. You can see live how actually in your brain symmetry breaks, and that each time symmetry breaks, actually frequency changes. So suppose ordering was hexagonal close packing and it becomes tetragonal. Okay, lattice shape changes. So what will happen is earlier it was vibrating at 60 hertz, now 50 hertz. So this shift is actually how the time crystal forms. So not the frequency, a collection of frequencies are not clock. When the frequency shifts, that is actually contributes to the formation of time crystal.
Okay, actually this question is from our speaker tomorrow, Dr. Deepankar Mondal. The questions that I just gave you were actually from Dr. Deepankar Mondal, who will be speaking tomorrow. Okay, the next question is, can you explain Boltzmann brain related to your topic, like simulating brain? That is, are we living in a simulating universe?
Oh, okay. Okay, so first chapter of my book is actually free. You can go to any website. You don't have to pay any price. It's free. So you just go to the first 10 examples of the different brain that we have given is Boltzmann brain. So that's why I do not want to get into details. But the second question is very important. Are we living in a simulating universe? I think I know many big scientists in the world are campaigning for this. Even some famous professor from MIT. But I don't believe. I don't believe that I don't believe in God. And if you try to establish God by any clever ways, I'm going to go against you. Because self-operating universe, the model we are proposing in terms of primes, pattern of primes, and here God has no position. And for your kind information, if you go to Vedas, the God is challenged. If you go to Sankhya Darshan, they proved logically that God cannot exist. They very asked question. If you go to Nyaya Shastra, again they ask questions that God cannot exist. I can show you hymns after hymns that nowhere in the Indian history you can find God was done. And you know, puja archana was created by in Mimamsa Shastra first time. And why it was created? To show you that God doesn't exist. So simulation, nobody is doing the simulation. It's self-operating system means self-operating system. So the attempt to bring in superstructure, super force in terms of simulation, it won't work.
Okay. Another question is from Dr. Monjima Bhattacharya. Does inductor block any of the AC or DC, or it can pass both?
Okay. Good question. So our patent on inductor is actually free, US patent. 2010 we filed. So you can search an inductor made of arrayed capacitors. If you just put in Google this phrase, or you go to my YouTube channel, you can find the videos. Like inductor, if you apply AC signal, it is blocked. But in our system, in inductor, if you apply AC signal at resonance frequencies, the inductor becomes invisible, so you can't see it. So that's what the result was there. I have not shown it. I have shown it only for DNA, but all the inductor devices actually disappear. They get vanish. That's why in the brain, neurons doesn't need to be ordered. Even if neuron is here, one neuron, far distant neuron, it can see in a particular time domain.
There are 3 or 4 more questions. Is it okay if I?
Yeah, it's okay. It's okay.
Okay.
It's okay.
Yeah. So from Dr. Monjima Bhattacharya again, can nanobrain be impregnated into the human body who is in coma?
We have done it on the animals, and human testing has not started. So currently, animal testing is going on.
Nilanjana Bagh asked, and it was also my question while I was hearing to that sound you were playing, that the frequency of thinking, how does it work? I mean, how is it recorded?
So okay. So we have a coaxial probe, atomic probe. We take the proteins, we go inside the neuron. So when neuron is firing, a neuron has a skin, just like my body has a skin. So what people do is they put a probe on the skin. For the last 50, 60 years, people are doing that on the skin. But we have another probe that is called coaxial atomic probe. So you can put it in Google, coaxial atomic probe, and you will see the pictures. So this coaxial atomic probe goes in deep inside the neuron and touch those filaments or strings. And those strings are simultaneously measured along with the skin. So skin actually does tick. And when one tick happens in millisecond, and the music I played was actually happening in microsecond. So all the music gets finished within 1 millisecond. Okay, so 2 different probes were there directly inserted into the neuron. One on the top to the skin to measure the millisecond one, another one inside the neuron to measure the microsecond.
There's one question from our 4th sem student, Tirthankar. He said, we see physical events in the form of optical vortex are being input, I think. What about a conscious problem like an equation?
Okay. So I think in chapter 4 of the book, we have described in details by drawing circles how you can do addition, subtraction, and all these things. And especially I avoided algebra in today's presentation because of short time. What to do then? Okay, so you go to my YouTube channel and then click chapter 4. The YouTube, the lecture is free. So you can see how using circles or clocks, you can do conscious problems like differentiation, integration. For example, 3 into 4. So what you do, you take 3 balls and inside each of the 3 balls, you put 4 balls. So you get 12. So multiplication means replacement. So clock replacement gives you multiplication. This is the simplest example of how a set of clocks can do addition, subtraction, and then any kind of partial differential equation. Many things you can solve. Actually, in the early days of my life, when I started building research, I used to do this kind of thing. So you can even go to our early papers 10, 12 years back. I used to do this kind of, lot of papers are there.
Okay. He also asks whether collective consciousness whether singular consciousness can affect collective consciousness, or is collective consciousness absolute?
Single consciousness can affect collective consciousness. It's a beautiful question. I would like to comment on this because it also means when I make this statement that single consciousness can affect the collective consciousness. Just think of Mahatma Gandhi. He changed the collective consciousness of the whole world. I went when I was in MIT, and I used to stay in a small village because I liked that place. And then even small kids, when I was talking to them, school kids, and they were telling me the philosophies of Mahatma Gandhi, and then I was so impressed that those kids. So he has changed. He has at least make a little difference to the collective consciousness of the whole planet. So one person can make a difference, but it has larger implications. It also means that humans can regulate God, if there is any.
Okay, Srijoni Mukherjee asks, sometimes it seems that we live in the reflection of the chain of past events. Why does it happen?
Because there is no past, present, and future. It's a clock architecture. It's a clock inside a clock inside a clock. So basically, you just think. You just think. There is you were doing something when you are 16 billions later. What will happen? You are part of that clock. Can you believe it? You are part of a clock of few million years later. What are the changes? You are changing because right now your heart cells are getting changed. It knows that after 110 years, it will replace the entire heart cells. So it is definitely doing it. So there are many clock inside a clock inside a clock. So definitely the past clocks are also running some of the events. So it's in the temporal architecture. It's not like the space you see. Spatial world and temporal world is very different. Here, if you have a circle, everything comes back. It's not finished. So that's why there is no past. So that is also a part of thing that is still happening somewhere in the 3D architecture of clocks.
Okay, Shuman Shordar asks, are you talking about chaos theory and butterfly effect in this?
No, I don't like it. I don't like chaos theory, and I don't like butterfly effect also. If there is any accident anywhere, I think there has to be some science for accident also.
Okay, and we have one question from our head, Tushar Ghosh. What are the similarities and differences between an animal brain and a nano brain, that is an artificial brain?
Okay. So the point is that there are 12. I have not discussed about the consciousness and how the machine gets consciousness and other things. Those are very complicated topic. So I have systematically avoided. But very to put very simply, a conscious machine is one that can create. Suppose I am a conscious machine. So I can create 3 information structures, 3 Anirban in one hardware. So that ability any machine gets, it will become conscious, because one Anirban will interact with the universe, like talking to you and something. One is in the environment where I am, another one in my internal systems. So 3 identities, if I can create, I can run a self-operational this temple-like architecture, mathematical architecture that you saw. If I want to run it, I have to create 3 Anirbans. Otherwise, I can't do it. So when we are building nano brain, then we are trying to impose this particular property, and we feel that that many animals have the ability.
And this is my question. The thing that you showed in your lab, how is it different from a robot? I mean, you have
okay. Robot have instructions. In robot, you list a set of instructions, and whatever you instruct, the robot does that. So you create millions and millions of lines of. So you need to imagine from your mind what is, if there is a little change, then the robot will not work.
Will not be.
But for us, it looks at the change of symmetries. So 86%, 80 to 90% times, it looks at the system, looks at how the symmetry would break. Even your sentences, when it listens to you, it looks at the breaking of the symmetries, and then accordingly, it finds out how it should respond to you. So it has no programming inside. And we are making only the brain, not the robotic machines. Then why does it look like a human body? Because for us, we need to build entire clock architecture. So the nerve systems, skin, everything we need to build. Because I have to cover all the clock, entire clock architecture. I cannot miss any clock. For the existing neuroscience, say everything. But for us, entire clock architecture is the source of intelligence. I mean, I can cut my hand. As far as clock architecture is not changed fundamentally, nothing changes. That's why some people don't have a brain, but it's still the thing. That Chinese lady didn't have the cerebellum, but still she could coordinate everything. It doesn't necessary that you have to have that part. It is necessary that you should have the clock architectures. Finite. So that's why it looks like a bot, but it is not a bot. It's the whole brain.
Okay. Okay. Okay, so thank you once again. That was a really wonderful experience for everyone. And as I told you that I am sure the entire audience is as intrigued and transfixed as I am. And I'm sure they will go back to your YouTube channels and they would want to get much more of this. And it's, I should thank you. Yeah, I should thank you for that also, because you have put it up for everyone to see and go through.
Yeah.
And I'm sure students will be interested because this is definitely a very, very lucrative upcoming career option for them if they can pursue it. So on the behalf of the yeah, so on the behalf of the Department of Physics and our college, I thank you once again. Thank you for giving us your time. And now you can go and take that sleep that seems to be so obviously lacking. Okay. Thank you, sir. Thank you.
আচ্ছা আচ্ছা